Hello everyone. Today I will show you some magnets and practical experiments of these magnets. We know that magnets have two main properties. The first property is that if we take a bar magnet and hang it with a string, the magnet always aligns itself in north and south direction. You know that. That means not only that, a magnet attracts iron towards itself, right? That means it has two properties. One is attractive property, and one is directive property. That means a magnet can be used to make a magnetic compass. Magnetic compass are used to find the directions of a particular place. Now I will show you some practical experiments with these magnets. Here you see we have an U-shaped magnet. You see this one. Here it is written, it is north and it is south, right? After that, I will show you another magnet that is also U-type magnet, right? Right? That is also U-type magnet. Here you see. Now I have another type of magnets like this one. These are also magnets. Besides that, there is another magnet here you see, but there is nothing written on it whether it is North Pole or South Pole. We'll find that. We'll show you how to find the poles of a magnet if it is not given. Here you see, the poles are not given, but you can find the poles, which one is North Pole and which one is South Pole, right? Now, there are beside these magnets, we have other magnets also. You see, there is another type of magnet. These are cylindrical magnets, right? This one and this one is also a cylindrical magnet, right? Besides that, there are another type of magnet. You see this one. This is also a magnet, right? There is a hole, a circular magnet, but there is a hole in the magnet, right? Now I will show you the properties, or you can find how to find the poles. Here you see there is nothing written which one is north pole, which one is south poles. You have to find which one is the north pole and which one is the south pole. But it is written here. It is north pole, it is south pole. With the help of this magnet, we can find the others poles of the magnets. For example, this one, right? You see this magnet, right? Here it is written north pole. Let us take what we are getting. You see this one, another type of magnet, right? Let's see what happens if we take it here. Here you see it is repelling the magnet. Here you see this one repelling and this one is attracting, right? That means you can find that this pole is north pole and this is south pole, because we know that in magnet dissimilar poles attract each other but similar poles repel each other, right? Because since this is north, this one is also north, this one is also north, because north you see there is a repulsion. You can find here that there is a repulsion in north and north pole. Let us see. You see this is repulsion, right? There is a repulsion you can find, right? And this is north south, that's why it is attractive. That means if it is south pole, it must be north pole, right? And here you see if it is north pole, there is a repulsion in this magnet. You see here there is a repulsion, right? Here you see there is a repulsion here, right? That means this is north pole and this is south pole. In this way we can find any other poles. Suppose this one, I don't know which one is north pole and which one is south pole. Let's see this one. Yes, it is attracting. That means it is North Pole because this is written here South Pole. That means it is North Pole, and it is South Pole, right? This is North Pole because it is attracting, and here you see that this is South Pole and it is repelling. You see here, this is repelling. Yeah, right? This is repelling, right? Repels means that the poles are opposite. The poles are similar, right? You see here, right? Here see this similar pole, this is north, this is south, there is attraction, right? If you move in this way, there is a repulsion here. North is repulsive, right? Here also you see this is repulsive because this is south pole. This is attractive because this is north pole. North and south attracts each other, or south or north repel each other, right? In this way, you can find the poles of the magnet, any magnet, right? If you know one of the magnets, like this one, north pole and south pole. Now here you see, let's see. Here you see, it attracts. That means if it is north pole, it must be south pole. And it is here, it is repelling this one, right? You see, this is repelling. You can see here that it repels, right? Repel each other, right? That means this is the north pole and this is the south pole. You see, this is south, this is north. The same way, if it is south, it must be north. North south again it is attraction. You see here, it is attraction. That means if it is south pole, it will be north pole, right? From this experiment, you can find the conclusion that similar poles repel each other, but opposite poles attract each other, right? With the help of this magnet, we can find in this magnet also which one is north pole and which one is south pole, right? Let's find. Here is see that. Let's see. Here see north south. There is an attraction between north pole and south pole, right? And if you move this one to here, you see there is a repulsion. That means this is south and south repulsion. Here you see north, this is repulsion, right? That means from this experiment we can conclude that similar poles repel each other, but opposite poles attract each other. Now we don't know which pole is which. From this, you can find that this is the north pole. That means this is south pole, right? This is the south pole. The upper one is the south pole. This is south pole, right? Now this one, you see, it is attracting, and this one is south pole. Now you see that south pole repel each other. You see here, these are repelling each other. Here you see, there is a repulsion, right? You see, you can see here that there is a repulsion, right? There is a repulsion. In this way, there is repulsion, and the other, it attracts each other. This attraction, that means opposite poles is attracting each other. But if we move around this one, that is, it is repelling each other. Here you see, they are repels each other, right? Repelling each other. In this way, we can find the different poles of the magnet. Suppose this one, I don't know the poles. You just see, take it, and it is attracting. Then if it is north pole, it is south pole, and it is north pole, right? If it is north pole, it will again attract. You see here, yes, it is attracting, right? In this way, you can find the poles of the magnet. If we know one of the magnet's poles, that is north and south, we can find any other magnet's poles, right? You can see there is another magnet. There is a hole in the magnet here also, right? You can see here. There you see, it is attracting, right? It is attracting. That means attracting means here you see there is attraction. That means these are dissimilar. This is opposite poles attract each other, and it is repelling. Here it is repelling, right? It is repelling in this way, repelling, right? That means it is dissimilar poles. From this experiment, we conclude that if the poles are similar, there will be repulsion, and if the poles are dissimilar, there is an attraction between them, right? You see here how they attract with each other, right? You see here, right? See this one. From this experiment, we conclude that we can find the difference of poles of the magnet with the help of a U magnet, right? It is written the North Pole and South Pole, right? And if we have a bar magnet, we can find the directions or poles of the magnet if we tie the magnet in the middle and hang it. The bar magnet will align itself in the north and south direction, right? And we will find the north and south direction. And with the help of this magnet, we make many instruments like magnetic compass, which helps us to find the directions. What we get in this experiment that there are two properties of main magnets. What is that? The one is that a magnet attracts iron, right? I am showing you how it attracts. You see here how the magnet attracts iron filings or iron particles. You see, these are iron particles. The iron, this is the magnet. You see here how it attracts all the iron particles. You see here, it attracts all the iron particles, right? This is iron filings or iron particles. You see? And you should know that there are many uses of magnets in our daily life. Magnets are used in computers. Magnets are used in mobile. Magnets are used in fans. Magnets are used in ATM card and various other in radios and electronics items. There are many uses of magnets. In speakers, you'll find magnets, right? And today, in the modern era, we have discovered the magnetic train also, right? And this way, what we find in the end with this experiment that there are three main properties of magnet. What is that? The first property of magnet is that a magnet can attract iron towards itself. Right? This is the first. You see, this is the first property. A magnet attracts iron towards itself. You see here, it's attracting all the magnets. This is the first property of magnet. And the second property is that if we align a magnet, if we take a bar magnet and tie it with a string and hang it, it always points for the north and south direction. That means a magnet have the property to find the directions. With the help of magnet, we make magnetic compass with which we can find the directions of a place. Right? These are the magnetic property, second magnetic property that a magnet can help to find the direction or directive property. First property is attractive property, second property is directive property, and there is another third property. What is that third property? Third property is that if there are two magnets, you see here, if there are two magnets, right? Here is a similar poles attract each other, but dissimilar poles repel each other. You see here, dissimilar poles repel each other. You see here, there is a repulsion. Here you see, repulsion, right? That means a magnet has three properties. One is attractive properties, second one is directive property, and third one is repulsive property. If there are two magnets, if the poles are similar, then it will show repulsive property. In the end, in the conclusion, what you can say that a magnet has three properties. One is attractive property, that means it can attract iron toward itself. And the second one, it has the directive property, that means a magnet, bar magnet always aligns itself in the north and south direction. That's why with the help of magnetic compass we can find the directions of a place. And third one is the repulsive property, that if the two magnets have the similar or same poles, they will repel each other. Dear friends, if you like this video, please subscribe, like, and share. Thank you, everybody, for watching this video.